Okay, so the first presentation is by Hans, Rutger, Bosker, and Ronny Bujok. And Hans is presenting.
Hi. Hi, everyone. Hope you had a good lunch. My name is Hans Rutger Bosker, and I'll be presenting work that I did together with my PhD student, Ronny, looking into whether we can recalibrate, whether we can reshape your perception of lexical stress. Now, my first premise in this talk is not going to be too controversial, because speech is variable.
Because it's like you know because you know how been wasting way too much time actually so it's like a big step. It's like I was like, okay.
I think I've made my point, right? So speech is variable. No utterance is alike. You've heard a zillion different likes here, and each one of them is acoustically unique. One was high-pitched, one was low-pitched, one was happy, one was sad, etc., etc. Still, somehow we manage to perceive one and the same word over and over again. How do we do this? How do we go from that variability in the acoustics to something as stable as word recognition in perception? Now, context helps, and I'll be focusing on two types of context: lexical and visual context. So imagine you encounter a talker, and this talker says the words platypus with a weird, strange fricative at the end. Based on your knowledge of English, you'll be able to understand that this person intends to produce the word platypus with an S at the end. And so you'll perceive the ambiguous fricative as an S. You'll use your lexical, the lexical context to interpret that variability in the acoustics. Conversely, if you were to encounter that ambiguous fricative in the context of giraffe, you would perceive an F, right? Now we call this phonemic restoration, and it shows that you use the lexical context immediately. The moment you hear that sound, you can interpret it based on what you know about English. Now, a similar phenomenon happens in the visual domain for visual context. So imagine you hear a sound that is ambiguous between a B and a D. Now, if you then hear that sound A in combination with V, a video of someone closing their lips while saying ba, you will perceive that ambiguous sound as ba. The audiovisual percept will be ba. Conversely, if you were to encounter that ambiguous sound in the context of a video of someone saying da, you will perceive da. And so visual context also guides your perception. This is known as the classic McGurk effect. But listeners are more clever than just this, right? There are effects that are immediate, like these two effects, but people also learn. People learn about how a given talker produces their sounds. And so imagine you are exposed over and over again to one talker who happens to produce, say, S's in this weird way, right? And so this person says platypus and house and conference. The next time you encounter that ambiguous fricative, you will have learned that this ambiguous fricative refers to S. And so next time you hear the word knife, you will interpret the word as being nice, not knife. Now, this is shown in experiments that use exposure and then a following test, right? So if you were to encounter this talker over and over again, and then get, say, an auditory continuum, a phonetic continuum, that gradually changes from S to F in incremental steps, you will be more likely to perceive that new continuum as more S-like if you encounter that talker, that ambiguous fricative in the context of S words, whereas the same continuum will be perceived as more F-like if you encounter it in the context of F-like words. And the same holds for visual context. Imagine you are encountering an ambiguous sound in between B and D, but you know that this sound should be a B because you've seen the lips close so many times. Then on a new occasion, and when you encounter audio only, right? When you encounter a new auditory continuum from B to D, you will perceive this continuum more B-like based on your learning over and over again in exposure, whereas another group will perceive the same audio-only continuum as more D-like. And so we call this recalibration. We change how you perceive certain sounds. It's also known as perceptual learning or phonetic retuning or talker adaptation. And studies into recalibration typically use this exposure test paradigm, where the test is the same for two different groups, but exposure is different, right? They get the same fricative or the same sounds, but in different contexts, which then leads to their differential behavior at test. Now, there's been a zillion studies into recalibration ever since 2003 or so, and most studies into recalibration have focused on the segmental level, have focused on consonants particularly, also some studies on vowels. But speech is more than just the letters, right? The way consonants and vowels are produced is also very informative. And here we talk about prosody. Prosody can distinguish a question from a statement, can distinguish happy from sad emotions, and can even influence word recognition when you talk about lexical stress. Lexical stress is a common phenomenon in many European languages. So in English, we have these minimal pairs like object, noun, and object, the verb, where they are segmentally rather similar, but they are different in where the stress lies, right? Stress on the first syllable, which I will refer to as strong, weak, SW, compared to stress on the second syllable, weak, strong, WS. You find the same kinds of pairs in other languages like Dutch, where you have words like kanon and kanon, where the first refers to a canon of historical items, I think, and kanon is cannon, a piece of artillery. And you find similar pairs in Spanish as part of a verb conjugation, actually, and so on for German, Italian, etc. Now, lexical stress is cued by prosodic acoustic factors like F0, greater intensity, longer duration, shallower spectral tilt, clearer vowel quality. But we know from the production literature, when we go and measure how people speak, that there's considerable variability in the prosodic domain too. So some people are F0ers, and they like to cue stressed syllables by raising their F0, whereas others may use intensity or prefer to use intensity. And so can we find that listeners learn about how a given talker produces lexical stress? In the first experiment, we tested 36 participants with this exposure test paradigm. In exposure, we had one group who heard an acoustic item that fell roughly in between Dutch kanon and kanon. So it's kind of ambiguous, not quite the one, not quite the other. It's ambiguous. However, every time they heard it on screen, there was this orthography indicating that it should be the SW member. So they saw CANON, indicating stress on the first syllable. On other trials in exposure, they got the clear other member. So they got the clear WS member, kanon, with matching orthography on screen. And so this group was supposed to learn that this particular talker happens to produce ambiguous cues to stress on the first syllable. Group 2 got the reverse. They got clear SW items, so they heard kanon with kanon on screen, but they got the ambiguous item paired with the orthography of the WS item, namely KANON, cueing stress on the second syllable. And so this group was supposed to learn that ambiguous cues actually weren't intended to refer to a WS item. Now, after only 48 trials of passive listening, we gave them a test, which was to categorize a phonetic continuum from kanon to kanon while varying F0. Now, what we find is that we get a clear group difference here, such that the same phonetic continuum, F0 continuum here, was perceived differently by the two groups, such that group 1 was more likely to perceive it as having stress on the first syllable, while group 2 perceived that continuum as more likely to have stress on the second syllable. Now, we wanted to see whether this learning is item specific. And so in experiment 2, we changed the exposure item. So the general gist is very similar, general design is very similar, but we changed the item. So instead of using kanon, kanon, we use service, service, Serbian tableware, I think. But the overall aim was the same. We wanted to teach these two groups that ambiguous cues to lexical stress QSW in group 1, but they QWS in group 2. Then, at test, we gave them the same kanon-kanon continuum from experiment 1. And here we find, again, this group difference, showing that people generalize their learning on service, service to a new word at test. I should point out here that the F0 trajectory, the F0 contour in kanon and service was actually identical. And I'll come back to this during the discussion. What we can see so far is that people learn about how a given talker produces lexical stress. People generalize this knowledge to new, novel words they haven't encountered before. And so lexical context can fundamentally reshape listeners' representations of what constitutes a stressed syllable. Now, what about visual context? Well, first thing to point out is that we had a separate project to see if facial articulatory cues could cue lexical stress to participants, to viewers, basically. And we failed. So when you say kanon or you say kanon, your face is different, right? The articulatory visual cues are different. However, listeners do not actually use those cues when listening to speech. And so we needed to look outside the face. Now, fortunately, conversation is more than just talking faces. But we speak with our entire bodies, right? Spoken communication is inherently multimodal. And so let's turn to beat gestures. Beat gestures are relatively simple up and down movements of the hands. They do not necessarily convey much meaning. I mean, there's no meaning in the beating of a hand. Still, they make up over 90% of our everyday gestures. Interestingly, the timing of these beat gestures is closely coupled to speech prosody. And so we beat on the stressed syllable. We say amlap. We don't say amlap with the beat on the second syllable. Now, in a separate project, we showed that this timing actually has a function in perception. And we termed this the manual McGurk effect. And so what we did was we randomly selected a native Dutch speaker, and we manipulated his speech to be ambiguous between kanon and kanon. And so what you'll hear here is two videos with the exact same audio. It's ambiguous, not quite one, it's not quite the other. But in one case, the talker produces a beat gesture on the first syllable, whereas in the second video, same audio, but the beat is on the second syllable. Go and have a look. Kanon. Kanon. Audio and video are a little bit out of sync here, but I assure you they were quite in sync during the experiment. So I hope you trust me for it. At least here are the data, right? So you see a lexical stress continuum on the x-axis and the proportion of responses of people hearing stress on the first syllable. And you see that if the beat is on the first syllable, there's an increase in that proportion of first syllable responses, basically. Now, Ronny set out to test whether this immediate manual McGurk effect, right, it changes your perception of that particular word, could also have more long-lasting consequences in the form of recalibration. And so in experiment 3, he tested 36 participants with that exposure test paradigm. In group 1, listeners got this ambiguous kanon item again, but this time it wasn't disambiguated by orthography, by lexical context, but by seeing the talker beat on the first syllable. And so group 1 was supposed to learn that this particular talker, strange talker, produces ambiguous cues to stress on the first syllable words. Group 2 got the reverse. They got the ambiguous item with a beat on the second syllable, hoping that they would learn that ambiguous cues to stress QWS words. And at test, they got an audio only, mind you, right? So exposure audiovisual test audio-only continuum from of canon to canon. And again, we get that group difference, showing indeed that people recalibrate their perception of lexical stress based on a simple waving of the hands. Now, experiment 4 tested the same generalization as before. So we used a different item, this time not service, but voornaam, first name, respectable. Same overall design, but just a different item in exposure, but the same canon test continuum. Do we then again find that generalization? Well, not so much. The generalized linear mixed model tells us there is some evidence for it, but it happens to be p is 0.051, which is just great. And so we're looking into this a little bit further. One thing is that in experiment 1 and 2, the F0 contour of service and canon were identical. So perhaps it's easier to generalize based on that identical F0 contour, whereas here, the two F0 contours were quite distinct. They weren't miles off, but they were more variable. And so we're looking into whether the acoustic difference between exposure item and test item has an effect on the effect size that we find here for generalization. But to wrap up, we see that people can recalibrate their representation of stressed syllables based on lexical context, orthography, experiment 1 and 2, and based on visual context, beat gestures. Now, for lexical context, we found generalization across words, and this has been taken in the literature as evidence for abstract representations of stressed syllables. And so these people in experiment 2, they had never encountered that canon continuum before. Still, based on their learning of this service item, they generalize that to canon items. And so there must be some form of abstraction here, also on a prosodic level. And at the same time, this then also showed that there is evidence for larger phonological units in perception, larger than phonemes alone. And so it shows that we should consider the units of speech perception to go beyond just the letters, right? Just the consonants and vowels. For visual context, we see that we didn't find the generalization across words. We're looking into this in further experiments, but they do show that these very simple hand movements impact not only that immediate perception of co-occurring speech in the Manuel-McGurk effect, but they also have the capability to reshape listeners' phonological representations. And so we demonstrate a lasting impact of these seemingly meaningless hand movements on perception, underlying the inherently multimodal nature of speech perception. Thank you very much.
Thank you very much. We've got a lot of time left for a lot of questions.
Very chivalrous. My name is Daniela Paleski from the Humboldt-Universität zu Berlin. I had a question. I don't know if the slides can come back for experiment 3. On the plot, it went quickly, so maybe I hope the question makes sense. But it seemed like there was a difference in the slide between the two groups, where in the middle, along the x-axis, it seems like group 2, I think, was at chance, whereas group 1 was at like 90%. Yeah.
There we go. Yep.
Yeah. So I was wondering if you have any idea for the differences between the two groups. In the middle there.
Yeah, I suppose it shows the impact of this kind of recalibration, right? So what is perceived as roughly an ambiguous item, right? So say step 4 in the middle there by group 2 is actually convincingly perceived as a SW item, around 90% of responses in group 1. And so it shows that group difference.
But for group 2, then if it were the same effect between the two groups, unless I've misunderstood something, then shouldn't it kind of be mirrored for group 2 for the proportion of SW responses?
It should be lower, you mean?
Yeah, because it seems to be at chance here.
Yeah. That depends on what continuum you use, I suppose, right?
Oh,
So imagine we hadn't tested step 2, 3, 4, 5, 6, but 2.5 and 3.5 and 4.5,
Okay.
if that had existed, then the overall effect of step would change, and so the proportions would drop or they would rise. But the critical thing here is the group difference. So the exact same sound is perceived differently by the two groups.
Yeah. Okay. But then just at that step, it seems like it might even just be more of a preference to the SW in general. Of course, the group differences of interest. But I think it's just interesting that group 2 is at chance, whereas group 1 is.
No, that's a very, very fair observation. Perhaps I should have plotted the, so we pre-tested all the continua before we actually ran the experiment. And so we also have data from people who only get test, basically.
Okay.
So who never get exposure. And I'm guessing, but I hope that's actually true, that line would fall in the middle.
Yeah. Okay.
Right? And so it's what we're seeing here is the push towards SW for group 1 and the push away from SW for group 2. Does that make sense?
Yeah.
Okay.
Great. Okay, thank you.
I know this is in the staff microphone, but I can't be bothered to walk all the way there. Sorry about that. I think, if I understood this correctly, a big part of what you said was that gesture is sort of speech adjacent, like visual cues and things like that. But I think this experiment would work with any sort of cue, including a flashing light or a change in air. And the fact that it didn't generalize kind of makes me think that even more. So I'd be curious to know what you'd say to that.
Well, definitely. I think it's something that we're, that is something we're looking into at the moment. We're considering using virtual reality, for instance, to carefully manipulate what visual cues we transmit while controlling everything else, basically. So we're thinking along the lines of more subtle visual cues that are still communicatively relevant. So something like an eyebrow raise or a blink or a head nod. But you could also go beyond communicatively relevant signals. So one experiment we are running is where we have a beat gesture, but in one case you just get the gesture, and so it's in a way communicatively relevant. In another case, the avatar is bouncing a basketball. And so there, the action itself is not that communicatively relevant. And so the motion, the visual cues themselves of the hand at least are identical, but do we get a difference in how people interpret that action basically in a socially relevant situation? And so this is something that's definitely of interest, absolutely.
Hi, Eleanor Shadra from York.
Hi.
I was wondering if you could explain a little bit more about the exact acoustic manipulation, since that seems somewhat relevant for
Absolutely. I actually have a backup slide.
Oh, perfect.
if we can go back to the slides. Yeah. So in experiment 1 and 2, in all experiments, it was an final one, the thank you slide, and then I'll proceed from there. So in all experiments, it was an F0 manipulation. We set all the intensity and duration values to be average, to be ambiguous between stressed and unstressed. But in experiment 1, we used a rather coarse-grained F0 contour, which was relatively flat. There was some declination within the syllable, but it was relatively flat and artificial. But critically, the cervis and the canon items received the same contour, and so perhaps that increased that generalization effect. In experiment 3 and 4, Ronny did a much better job, namely to interpolate the F0 trajectories point by point. And so the highlighted, the lines in bold, are the ones used for canon, the 5 steps for the canon continuum. And so the middle one is the ambiguous item, whereas the one for voornaam is actually a little bit different. And so we think that this distinction, this difference, led people to generalize less, if you will.
I see. So is it almost like there's a pitch accent, that's happening?
Yeah, the pitch accent is present for both canon and voornaam, but it could be more pronounced or more extreme for voornaam.
Thank you.
I hope that clarifies.
Any other question? Okay, so let's thank the speaker once again. Thank you very much.